Hi students, Mrs. Keller here. Just wanted to talk to you about how to fill in the radians on your unit circle. So let's get started. Remember, our angles in standard position always start here from the positive x-axis. And in radians, we start here with 0 radians. And then if we go all the way around the circle, we will have 2 pi radians. So the way I fill in the radians is I kind of think about it, if all the way around is 2 pi, then halfway around, or 180 degrees, is going to be exactly pi radians. So I have to bear with the handwriting here on my mouse. So halfway around is going to be pi radians. So then, if I think from here to here is pi radians, halfway would be right up here. And so this is going to be a half of a pi. So this will be pi over 2 radians. And then so I went 1/2, 2 halves, or 1. So then this becomes 3 halves. So 3 pi over 2. And then here's another half of a pi, which is 4 halves, which is equivalent to 2 pi. The first thing I like to do is I fill in all of those values. 0, pi over 2, pi, 3 pi over 2, and back to 2 pi once we're all the way around. So then I want to think about, so from here to here is pi, I want to think about these middle pieces here. And so basically this point right here, this angle is halfway between 0 and pi over 2. So this is a half of a pi, so halfway between is going to be pi over 4, or a fourth of a pi. So pi over 4. So now I'm basically going to count every one of these little 45 degrees here is 1/4 of pi radian. So if I count by fourths, this is 1/4, then this is 2/4, which reduces to 1/2, right? This is 3/4 here at this point. So this will be 3 pi over 4. All right, 4/4, which is equal to 1. This point will be, you guessed it, 5/4, or 5 pi over 4. 6/4, which is 3 halves. And then this last one is going to be 7/4, so 7 pi over 4. Back up here would be 8/4, which is equivalent to 2 pi. So now we filled in all of these little halfway between our main axes. So that leaves us to these last little bits. And if we think about these last little bits, I'm going to choose another color. Thinking again here from 0 to pi, if I ignore this middle piece for just a moment and just look here and here and, oh, that's bad, erase. It's really hard to draw with a mouse, y'all. And here, let's see if I can go this way. This one and this one. I've basically taken this pi radians and I've divided it into 6 equal pieces. 1, 2, 3, 4, 5, and 6. So each one of these is going to be a 1/6 of a pi. So that means this point right here is going to be pi over 6. So that's 1/6. Here I get to 2/6, which reduces. 2/6 is the same thing as 1/3. So this is really pi over 3. Here I'm at 3/6, which reduces to 1/2. So we already have our pi over 2. 4/6 reduces to 2/3. So 2 pi over 3. Then this is 5/6, which doesn't reduce. So 5 pi over 3. Whoops, 5 pi over 6. Erase. 5 pi over 6. And if we continue going around, this would be 6 sixths. So this would be 7 sixths for this point here. So 7 pi over 6. This would be 8 sixths, which reduces, I'm out of room, so I'll go here, to 4 pi over 3. 9 sixths reduces to 3 halves. 10 sixths reduces to 5 pi over 3. And then this would be 11 sixths. 11 pi over 6. We'd get back to the beginning and it would be 12 sixths, which there again reduces to 2. So now we've filled in all of our angles in radians. Once you know how to fill in your unit circle in radians, you can do the same thing you did with the degrees and that we showed in the last video, which is to take any of these points and to find the cosine and sine, you simply look at the coordinates of those points. So once you have your unit circle all filled in with your radians and degrees, you can find cosine and sine of any angle immediately just by looking at the coordinates. I hope this was really helpful. Please feel free to reach out to me if you have any other questions. I miss you.